Hello everybody and welcome back to Micronova Metals. I have a new toll job that I'm starting on right now, and it's a number of things actually. So I'm going to start with gold filled, and let's see what he's got for me. Alright, that's 40 grams right there that I'm going to have to put some flame to incinerate. Just Google just AI'd this, and they said this is a gold plated pin. I don't know if Google knows the difference between plated and gold filled, but it's in a gold filled pile, so it's going to go in. A couple of items here have some magnet to them. That makes me a little sad because I'd love to just put this in with some carrot scrap and quart it with some silver. This here, no magnetism, but there's a little bit of a spring. Very, very little metal, so it's that's going to go into. And I have some sterling to do here. I also have some Mexican silver, and I've started to catalog these coins and going on to Google, and some of these have a 70+% composition to them. Some of them have nothing, or as little as 10%. So I'll have to talk to my client and see how he feels about that, and just give him an expectation on the actual yields. There's also some U.S. Constitutional right here, which I'm going to talk to my client and see if I can rescue that, because I'd rather not melt it down and just give him some of my own bullion. But again, we'll see how he feels about that. And then the last thing is some carrot scrap. And so I'm not going to weigh all this for you right now. It's just as we go, we'll do this this video in segments, and they're probably not going to be the long explanation videos I do and instructional things that I do, but just more of like little snippets and screenshots as I go along. Okay, and I don't know exactly how much this is going to take, but I think we're going to start by putting, let's say, 30 mLs into this. It'll be more than enough to get it started. I'm going to just dose it in real quick. I'm going to put all of it in, and then I'll put it up on, at first, a cold plate and then some mild heat. And it will probably just react with the water alone, but it's going to start a reaction there pretty quick. There we go. Get it up to here. And just watch it do its work for a minute. I'll go get a watch glass for it. That's a nice, healthy reaction. We'll get it contained. And the idea with gold filled is that it's got a heavy gold plating, usually 1/20th or 1/10 of the total weight of the base metals would have that weight in gold of whatever carat reading it's given, whether it's 10K gold filled, 12K or 14K. I've seen some 18K as well, but what will happen is the acid will will penetrate spots on that jewelry and those pendants, and it will just release those foils, and they'll be floating around. And we need to get all the base metals dissolved. Okay, while the gold filled is doing its thing, next up is going to be the carrot scrap. It's not much, but it just be added to the sum total. That's weighing out at 4 grams. I've got some silver from a previous project that I'm going to quart. So I'm going to take this over to my melt station, turn it into shot, and it will wait its turn to go into some glass and some acids. Okay, next up are these blobs and bars that I was told by the client are actually 90% from, I believe, he didn't say U.S. constitutional coins, but I do believe that's it. So, got this little puck, bar, a puck. I don't know what that is. Another little blob, a little puck, and another little bar. So that is 122 grams rather of what is supposed to be constitutional silver, now melted down. So off to the melt table we go with that, so I can turn it into shot, and the chunkier pieces won't take quite so long to melt. In that crucible is the 90% coinage that I just melted down into shot, which is, you know, right here, right now. But look at this blob. Right there. All that crap. This is a brand new crucible, and I've more than likely lost it because that's metastatic acid, which is what happens when you put nitric acid into something with tin. And there was probably a coin in there that had some tin and zinc in it, and that's how that resulted. There is some silver in there, but it's not. At the moment, I'm going to consider it a loss. I can't get at that without expending a lot of MAP gas, and I got to move on. And speaking of moving on, let's get a weight of what we have recovered from that. There is this mixture of copper and a little bit of silver in there, and that metastatic acid, which will just contaminate everything if I were to put it in there. So let's get the shot on the plate. Still a little bit of water. Go, all that's just borax from the dish. So we're at 120 grains plus a little bit of water weight, and the pucks were 122. The pucks and bars were 122 grains total. So we only lost I keep saying grams. So we only lost 2 grams. That's not bad. Let's just say we lost 3 because there's water weight on that dish. Okay, we are ready to move on to another phase of this project, and that phase is to get the unquarted gold in there. So we've already got a measurement on this. So we got 17 grams of shot in there, and that includes the 4 grams of, oh, I'm sorry, it took some time, up to 19. That actually makes sense, because there's 15 grams of silver that I refined on a previous personal job, and then there was 4 grams of gold that we alloyed together. So what we're going to do is put some distilled water in there and give it a nitric boil. And what's going to happen is the nitric will eat all the silver and dissolve it in all base metals, any copper or anything else that is in there that is not gold, and it will leave behind little gold nuggets, in which we will clean up and refine from that point. So we're going to put everything else into solution and be on our way to collecting tiny little gold nuggets. Distilled water, in this case more than enough to cover up the shot. And then we'll go ahead and put it up on the heating pad. I considered putting all of my clients' sterling silver in with this, but then I wouldn't be able to easily part out my 15 grams of silver, so we're going to do it separately. So this is just under 30 mLs of red fuming nitric acid, and I'm really accounting for about the 1 milliliter of acid needed to dissolve silver, which is almost a 1-to-1. I think it's a 1.22 milliliters of nitric acid to dissolve 1 gram of silver. And the copper in there is almost a non-existent factor, simply because there was only 4 grams of karat gold in there, so it's nominal. So the 30 milliliters will get us 2 or just shy of actually dissolving all the base metals, including the silver, and putting it all into solution. While we're doing this, we're going to check on the gold filled project. And something I forgot to mention at this point is there was a nice robust ring in here. And when I was looking it over to confirm that it was gold filled by markings, the ring I saw, it said gold filled over sterling. So that's good news for my client, because he's got a little bit more silver coming his way. So I'm going to take a quick look at this. Let's see what we got. Got foils down there. It looks like a very, very saturated solution to me. I think we're going to need to put some hydration in that. So we'll go ahead and do that. And then just put the heat back to it. I'm not going to even add any nitric until there's more water in there. What that will do for us is just see if there's any free nitric in there. It'll start doing its work when there's more saturation. That should do right there. And back onto the heat. Here we go. Watch glass, and we will check in soon. So here's a little something I dropped the ball on. If you look right down here, that's silver chloride already coming out of solution. And the reason why that's there is because when I poured the shot into my quenching bucket, that's water from my tap. And I have a private well, but apparently certain minerals that are in the well, along with the iron, will force silver out of solution into silver chloride. But that will give it enough time under the nitric that will go into solution. So I was too busy running my yip and I forgot something. This is all the constitutional silver that came from my client to me in the form of small bars and little pucks. I had to ask him what all that stuff was, and it was constitutional silver that he had melted down. So I've got to add this in. Which means we're going to need more acid, but we'll use up what we got. And that is, it's okay to go on top of the shot with the carat scrap in it, the unquarted gold, because all that silver is just going to go into solution. So, and if you look close, got a little snow globe action in there, and that's because this coin, I almost said coin silver, the 90% silver was also quenched in that same tap water. So silver chloride until it's not anymore. Let's go ahead and add in some more nitric, since we have another 120 grams of 90% silver. We're going to need it. All right, here we go. All right, some good news. We're starting to see foils floating around. I did just add a splash of nitric, and hopefully what we'll see is a lot more of that. And basically what happens is the nitric eats it from the inside out and leaves these very hollow and very light shells. It's still in the shape typically of what they used to be. And there's not going to be much here. It's going to be nearly weightless, but just like the amount that's in this over here in the unquartered silver, 4 grams. Not weightless, but you know, given the carat value, it's going to be, I think it was a little bit more than, I think it may have been 14 karat or a mix of 14 and 10. Regardless, not a lot of weight, but we add it together and just get a little bit more, right? All right, it appears that we have not enough saturation here because we have more than enough nitric. I will say that if you do this, you gotta be ready when you're adding saturation sometimes to get a quick reaction. Now that's super cold water, so it's going to dumb down the heat. And the other thing is, once again, I prove that it takes me 2 hours to watch 60 minutes, because if I could put that 90% in there, I could put this in there too. So I am going to go ahead and do that. We're going to get a weight on that real quick. And we'll go ahead and get a weight of it in the bag. I have verified all this is sterling, at least by the markings. That's 67 with the bag. And it's all super lightweight stuff. It's going to go up pretty quickly as long as we have the right combination of hydration and acid. This is something too that you could run into trouble with if you're not careful, adding fresh material to a stagnant batch. So I'm going to leave that there until we get a reaction started, and then I'll gauge it from there. So this whole project here is just going slower than it should. And I am running out of room to add hydration. And that's super dark blue. I looked at it and just picked it up. Maybe I can show you on the bottom. It's those two pendants. Yeah, you're not going to be able to see it, but they are there, and they're not dissolving yet. But I've also just been feathering this stuff in, so it's going to get to the point where I can't add any more in, and I'm going to have to decant it and do fresh nitric on whatever's left and capture the foils in a filter. Okay, little adjustments. We may as well go and add some more nitric to this one too. We're going to go for 20 ml. Something in progress, you want to go slow. Nothing crazy going on. All right, right, but it's also just starting to heat up after getting that super cold distilled water put in there real quick. So that's going and that's going, and we're just going to keep shifting between the two. Okay, so here's where we're at. This is pointed at the gold filled right now, and it's just kind of chugging along. I can see foil floating around. I think we're going to end up decanting that. It's just not going to be tonight. I'm gonna shut it down, and before I go to bed, and just refresh it tomorrow. And over here, not much has changed since I added the last bit of this jewelry, so I'm going to add the rest. Here's what's in here. Yeah, that needs saturation too. Better give this a think real quick. Yeah, I'm going to add some saturation to that. And some more. I've got a good idea what it's going to take anyway, so I may as well get it up to that level. That should be ample and give us a little space to let it grow if we need to. When you see nitric just appear like that out of nowhere, that means the solution's dehydrated. There we go. All nice and empty. Okay, I like where we're at. We're going in a good direction. Oh, let's see, what's that? I see some sparkles. The kind that shouldn't be there. I have a hard time capturing it with the use of this headlamp. And you can see some deplating of that oh, it's probably an earring. I think that's right in front of us. So unfortunately, I think I'm going to have to tell my client that what he thought was sterling is actually plated. Otherwise, it wouldn't have sparkles flying around like that. And yeah, it's disappointing, but that's an up close. You can see some sort of a base metal underneath there, and I'm watching it erode away as we speak. That top left area is getting darker and darker, more exposed space. So that's going to reduce our total yield, but it's just what's happening. Okay, starting day 2 of the toll refine job. We're going to decant what we've got here because I made a discovery last night, which you'll see earlier on this video, that some of this stuff is not like the other. Simply meaning that this is not all sterling jewelry in here. My client's been kind of taken on that a bit. And you'll see some silver chloride forming in the bottom of that vacuum flask. That's fine because I was going to do an immediate conversion anyway. I'm going to start this, filter it out, and then I'm going to go through what's left in the beaker, take out what I know is junk, and then start a fresh nitric bath with the other silver that I poured into shot this morning, and we'll just get a whole fresh reaction started and remove junk in the meantime. Okay, and the other thing we're going to do is this is the gold-filled project. It's mostly foils in the bottom, but like I said, I know that there was a very robust gold-filled sterling ring there, so I'm going to pour this out and I'm going to filter it and get ready to process the foils that are in there. And I need to investigate what's in there. Okay, so while that is filtering, let's go over what we've got left. Let's see, get my little pointer stick here. So right down here is the remainder of the shot. Most of that is dissolved. And remember, some of that's going to be the gold carat scrap. So this has to be fully dissolved so I can even find it. And there's some of that jewelry in there. Some of that might still be plated, but it has silver cemented onto it, so we're going to let it rock and roll. And I got to get this fully dissolved, especially to find that gold. So I think I see some of the stuff, yeah. But anyway, I have more shot. Let me grab it real quick because I'm just going to add to it. So this is the shot. I melted up this morning. This is from a mixture of Guatemalan, Canadian silver, and Mexican silver. And everything that's in here is 925 from, I believe that was from Mexico. There was some 720 from Guatemala, and there was some pretty high purity silver from, oh geez, now I'm trying to remember exactly where it came from. Let me think about that for a second. And here's my cataloging here. So there was some Mexican silver from 61, 66, 63, 1958, 10%. 10%, according to Google Pants, 70% copper, and then there's zinc and nickel in it. So I'm not melting any of those. I'm just going to send them back to the client. It just isn't worth a squeeze, and I don't think it would do good things for my solution. What else in there? There was 1920, 1921, 50 centavo, and that was 72% silver, 28% copper, so that went into the crucible. And a Indie Nerdu, won't even pretend to know what that means, but that was 72%, so that went in. Australia, all their stuff from 1921 up to 1944 was 925. There was florin, 1941, 925. Shillings, 3 pences, all that stuff, all was sterling, so that all went in, and I took pictures of weights. And then Canada, 80% silver. There were a bunch of dimes, in all 80%. The one that we weren't sure about was the mackerel dime, 50 to 80%. But I think it was probably 80%. So all that went in. Pardon me. And then of course from Guatemala, right there, 720. So that's what we came up with as I was sorting it in catalog. While we're waiting for that to filter out, here's the Mexican silver I did not send in the Canadian silver. And why is that? Well, this one here would not melt. Magnetic. Also Canadian dime that was magnetic. I had to ask, how do I tell the difference between the 80% and the not percent during the transition years? And it turned out to be just the case that some were nickel and other alloys, and some were not. So if they're magnetic, then no. But these are the 5 Mexican coins. They're not magnetic or anything. They're just full of copper and other stuff that I don't have any use for, and maybe he can gift them. But there's not enough in there to even bother putting the map gas to it. I've also decided to put these back into the reaction because they have cemented silver all over it. But let me show you this. This example of this plating. I guess this was Walmart clearance, and I've been there myself and almost bought some. I'm glad I didn't, because it isn't sterling like they advertised. If you look up in that upper region right there, you can see where that plating comes off, and it's actually sparkly. It doesn't even look like real silver. But for the sake of the fact that there is some cemented silver on here, I'm just going to add it back in. I mean, what can dissolve will dissolve, and where was the showing him pictures of? Yeah, it's hard to see on camera, but this was plated stuff. So back in it goes because of the cemented silver. Otherwise, I would not waste my time or the acids. But it's not that big of a deal. All right, we'll get that going soon. Okay, so the gold filled project is decanted off, and I am going to give that a fresh nitric and distilled water boil as well, just to make sure that that's good and clean. Those pendants that you see down there, the round pieces, those foils want to come off, but they have not come off yet. Okay, so we have gold foils, and that is gold filled that actually produced some silver, which you can see there's some silver chloride here. This down here, plenty of silver in it too. I just haven't dropped it out yet. So lots more silver in that, just dissolving away, and that's probably not even going to be done tonight. But when I drop this into there, there's probably going to be some more silver chloride formed. This is going to be, this 3-liter container is for the entirety of the job. All right. It can be a pain to get out sometimes, but there you go. All right, we'll get that cleaned up, stashed back into the vent hood. Okay, I'm going to get this started on the Aqua Regia started on the gold foils. Just enough to cover it, because there's not a lot. And it's there, but it isn't a lot. So I'm just gonna drip out a little, or I'm sorry, not drip out. I'm going to pipe in a little bit of nitric, and then get it up, sitting on the hot plate, get it into solution. It's about 3 ml right there. Total about 5, a little bit more, just a little more. There we go. It's a dilute Aqua Regia, and we're not done using it yet. We're actually going to add to it, but I'm just trying to kind of not speed date this, but I need to get the job moving along so I can do a quick turnaround and have a happy client. And so it's going to be up there in a little watch glass sitting on top of it. And actually, I need to get a little sulfuric acid into that too, come to think of it. Okay, a little concentrated sulfuric acid. What we want to do is precipitate out any lead. There is going to be some contaminants in this, and it will require a couple refinings, but the sulfuric acid will help dissolve the filter paper, and it will precipitate out lead. Here we are about 9:30 at night, doing a second filtering of the solution from the gold fill. That was 54 grams, roughly 54 grams, and we're hoping to get between 2.5 to 2.7, out of that. I did notice one of the pieces was 1/30th, which is something I think I mentioned, but something I had not seen before. Okay, Stannis test on gold filled. we go. Positive test. It's a good day. Alright, I've got some hot water heating up right now to get ready for an SMB drop like that, because I like to put my SMB in a little small beaker and super saturate it to the point where the SMB is too much for the solutions and some of it drops to the bottom. So while I'm waiting for that to heat up, I'm doing this. Get this decanted off, put it into here, and we'll drop that into silver chloride tonight. Before I'm done, we are getting this job wound up. Okay, well, that silver nitrate is finishing its filtration. I gotta show you this. This is awesome. All those little black beads in there and everything, that's the shot that I incorporated with gold. So I'm gonna give them their own separate nitric boil, get them cleaned up, and somehow get all those little cubic zirconias and whatever out of there. So I'm on a roll tonight, so I may as well keep going. Okay, time to add this silver nitrate solution to the sum total. Give this a nice little rinse, and then we are going to convert this to silver chloride. All right, looking good. And next order of operations, hydrochloric acid. Let's go make a cloud. Cool. Let's see. I'll get my stirring rod. So we'll get this stirred in, do the conversion, let it settle overnight. And then we'll do the silver chloride to silver oxide conversion after that. Alright, I'm just going to carry on getting this mixed in. It's quite thick, it's still converting. Yeah, it's almost the point where it's going to stand up on its own. Okay, well, that's enough for now. I'm just going to complete the conversion and then get this stashed away. There we go. Enough silver chloride, so when you give it a stir, quite a bit of resistance. Stop, it settles real fast. And then boom, there it is. Okay, so the plan is SMB drop this gold. We're going to let it settle because, as I just showed you, I have a bunch of incorporated gold shot in the bottom of the other beaker, and I'll get that to its first filtration and first drop, and then we'll combine these two. Quick change of color. It's going. I'd like to go a little faster. There we go. There we go. Perfect. I'm not going to add any more. Okay, so I'm going to put that on literally on the back burner and move on to sorting out this incorporated gold right here and getting the debris out of it. Alright, let's see if we can get a positive stannous test. We have it. Not actually really expecting more than a gram out of this. I'm surprised I've got such a dark stain, but maybe there's more than I thought. Okay, this is the second gold drop. This one's going to be the carat scrap. color change. So this might go completely clear, and then it'll come back to us in a dark color, but I'll put it up on another burner. But that's the that is something I saw just one time before. It's getting darker on us already. There we go. It's an interesting way that works. Give it a little spritz on the surface. And we'll get up on the heat, help it. Okay, this is the gold mud from the gold-filled jewelry. It would be a maximum of 2.9 grams unless something in there was super heavy or a higher carat value. But we did the hot water rinse. It's already looking good, so now we're going to put some hydrochloric acid in there and boil it. So this is gold from the carat scrap, and I'm surprised again. Not that it's a huge amount, but it's way more than I thought it was going to be. And just like the other one, it will, it'll reduce down to not much. But it's enough to process. Okay, and back to the gold filled. This is now twice refined. Rinsed, boiled in hydrochloric acid a couple times and hot water a couple times, and now rinsed thoroughly. And so we are off to the melt dish with this one. All right, ammonia test is complete. 4 rinses ago, there was a slight hue to it, a blue or purplish hue, and now it's crystal clear. I've gone through over 2.5 gallons of distilled water to get it to this. Okay, I haven't captured every moment like I normally do, but the rinsing is done on this cement silver. It's gorgeous, but I want to show you how clear these rinses are at this point. So get in there, stir it up, move the powder around, get that out of the way, move it around. There's not even any fine particulates that are coming off, like as in like no dust or anything like that, right? So I didn't count how many rinses this is, but I will tell you it's at least 1.5 gallons of distilled water, because that's all I use is just distilled. And look how clear this water is, so crystal crystalline clear. And I did the ammonia test earlier when I was checking for purity with the silver chloride, and first test showed there was still some copper, and then another 3 or 4 tests later it showed crystal clear. So this is ready to go. This is all set for the Corningware. Dry it up, and we will melt it tomorrow.